Here is the next example. There are three loads connected in parallel. Do you know how the loads are connected in your home? Are they connected in parallel series or parallel series combination or star delta? At home, the loads are always connected in parallel. Okay, only the Christmas lights are connected in series. Other than that, I don't think anything else is connected in series in your home. Everything is going to be in parallel. Now, if you look at load 1 is consuming 1200 watt at a 0.8 lagging power factor. Okay, you see, whenever you see this lagging power factor, that's inductive load. Okay, so inductive load is nothing but whenever a rotating machine, so a motor, which is always inductive load. So probably this could be a washer, okay, with a lagging power factor, and 1000 volt ampere unity power factor. Unity power factor means it's a pure resistive load. Okay, pure resistive load, your iron box is always consumes around 1000 watt around. So I can say this is iron. That's your iron box, iron your clothes. And the third one is load 3, 400 VAR at 0.9 leading power factor. I don't think anything we have in our home has a leading power factor. Everything either has electrical motor or a pure resistor which produces heat. I mean your electric stove or dryer, iron box, these things. Okay, time being, let me take this as load 3. Load 3 has 0.9 leading power factor. Now the question he's asking about, what is the total power supplied by the source? P, Q, S, P total, Q total, S total, and cos theta total. What is the power factor of the source, as well as what is the current path supplied by the source? That's what. So that you know the current rating, so you know what kind of wire you want to use for this big wire. Okay, this wire thickness is different than this wire, and this wire. Okay, now here load 1 is 1200 watt 0.8. So what I'm going to do, I'm going to find P1 Q1 for each load. That's my main goal. I can do it in different ways. Here the given value is P1 is Vi cos theta, which is 1200 watt, and from there cos theta value is given, which is 0.8. So from here I found S1, and then S1 is nothing but P1 P over 0.8. Okay, because S is nothing but Vi conjugate. So what is the difference between Vi and Vi conjugate? These two are different, right? Say if Vi conjugate, say V is 120 volt, say I is, I don't have number, but time being I'm going to take this as 24. Okay, so if I equal to 24 at an angle of minus 36.86, I conjugate is 24 at an angle of positive 36.86. But when I'm finding S, I'm using only magnitudes. Okay, I'm not using the phase angle, so it doesn't matter. This conjugate is not going to make much big difference. So that's the reason I'm saying S1 is nothing but P over cos theta. Okay, so this is one way to do it. So for all three loads, what we need to do, we need to find P1 Q1, P2 Q2, P3 Q3. And there are different ways. So I used here, I'm going to tell you another way. So if you look at load 1, I'm going to draw a vector, vector diagram. So here is my P1. Okay, and I need to find theta 1. So let me take this as P1 equal to 1200 watt, and this is Q1, that is S1, this is theta 1. What is theta 1? Theta 1 equal to cos inverse of 0.8, which is 36.86. Okay, So I know this value is 36.86. So based on this, can I find, by using this power triangle, we call this as power triangle, can I say vector diagram? I didn't see anywhere in the past calling this as vector diagram. We always call this as a power triangle. Okay, sorry, I call this as a vector, but vector diagram, it's a power triangle. Okay, now I know S1, P1, and I don't know S1. I know theta1 and P1. Can I find Q1? So Q1, can I say tan theta equal to opposite over adjacent, Q1 over P1. So based on that, you can find Q1, so which is 900 in this case. So there are two ways. One is you can find it by using the power triangle, P1 and Q1. All I care for P1 and Q1. Okay, so P1 is 1200, Q1 is 900. So now S, instead of keeping them separate, I'm going to write it in complex format. Complex part format, it is P plus JQ, because P consumed by this load, Q also consumed by the load. Since it's an inductive load always consumes Q. So this is 1200 plus J 900 volt ampere. Now load 2 has unity power factor. Okay, so unity power factor means what is cos theta? Cos theta equal to 0. So when I draw a power triangle for this, this is my P. Okay, at the same time, Q must be 0. So that's a P, and Q must be 0 because theta is 0. I'm just drawing a triangle so that you know, you can see P, Q, S and separate. Okay, so this is 0 degrees. So can I say Q equal to 0? So can I say S equal to P? Okay, so if you have this 0 degrees, this is not per square, per scale, but I just want you to see the difference between S line, Q line and P line. So that's the reason I draw a triangle, but in reality it's just a straight line. That is nothing but P, that is nothing but S, P and S. Okay, so the given value is 1000 volt ampere. That's a S value. Okay, it's not Q, it's S value. Now, so what is from this, what is the S2? S2 equal to 1000 plus J0 by using the triangle. Or if you want to do it another way, P2 equal to Vi cos theta, which is 1000 watt, cos theta equal to 1, and that's what he gave you. Now the third load, load 3, you have 400 volt ampere reactive and 0.9 leading power factor. So if I draw a power triangle for this, I'm going to use that part. So if I draw the power triangle, this is P3, that is Q3 and S3. So by using cos inverse of 0.9, this must be 25.84 degrees. Okay, now usually when you look at the coordinate system, this is positive real and positive J, this is imaginary J, negative real. Okay, when I draw this diagram in the load 1, I should have drawn this towards down instead of towards up, because no, actually it's going to be both of them are positive, so leave it as it is. That's P and Q, that's S. Here I'm going to draw this in reverse direction, sorry about that, since Q is going to be negative in this case. Why it is negative, I'll tell you in a minute. Okay, now I know this angle as 25.84 degrees. Okay, so that's P3. He said it's a leading power factor. Leading means definitely that's a capacitive load. Capacitive load always supply back reactive power. It does not consume reactive power, it supply back. So basically that load, it is taking active power P, but giving you back reactive power. So S3 is always minus JQ. So whenever you see leading power factor, that is because capacitive load. So whenever you see capacitive load, it is always minus J. Okay. Now from this, I know this value has 400. Okay, if I use the triangle, I'm not following these calculations, but definitely you can follow these calculations. Up to you which way you wanted to do. Okay, now P3 equal to, can I say tan theta equal to Q3 over P3. I know theta value, I know Q3 value, I mean theta 3 value, and P3 Q3 value. I can find P3 and up with 825.89, or you can use this procedure. Now, as I mentioned, at the end, our goal is finding the total power supplied by the source, total active power, reactive power, and apparent power. So S equal to S1 plus S2 plus S3. Here, I always want you to use the complex powers. Do not use apparent powers. Okay, if you use apparent powers, say one is 200 kVA plus 600 kVA plus 800 kVA. I'm just taking hypothetical numbers. You will not find exact S, because some of them are producing reactive power, some of them are consuming reactive power, and that does not reflect if you use apparent power. So you have to use the complex numbers, not the magnitudes, or not the apparent powers, or yeah. So use complex power. So P1 plus JQ1, P2 plus JQ2, P3 plus JQ3. So in this case, I have minus there. I mean, it's a general form of equation. It's not related to this. Okay, PQ plus J3, QQ3. So in this case, it's minus. To avoid confusion, I'm going to put it as minus. Okay, so I use 1200 plus J900, 1000 plus J0, 825 point. So at the end, I end up with 3025.89 reactive power, and plus J500, which is reactive power, JQ plus JQ. So it is taking, so remember, first load needs around 900 watts of reactive power. Third load is producing 400, so it is total they are taking only 500 from the source, from the supply. Okay. So SC is nothing but square root of P square plus Q square. You end up with the magnitude. Now cos theta as P over S, which is 3025.89 over 3066.92, so 0.986 lagging. Now if I want to find current, I equal to can I say P equal to Vi cos theta. So I know P value, V value, I need I value. So P, which is 3025.89 divided by the given voltage, I believe that's 120 volts. That's what I gave you at the starting. So 120 times 0.986. That's the